Hi, my name is K. Pakshirajan. I am working as a professor in the Department of Biosciences and Bioengineering at IITGuwahati. Our research mainly focuses on bioengineered systems for the detoxification of polluted or contaminated environment. We mainly specialize in bioreactors, their design and operation for treating different kind of waste. We have extensively studied on the remediation of endocrine disrupting chemicals by using certain microorganisms which are specialized to degrade and detoxify these chemicals from the environment. And we have also studied the heavy metal removal by biological sulfate reduction process, so which is a very specialized group of organisms that they perform this task, and these are anaerobic sulfate reducing bacteria. And we also focus on converting toxic carbon monoxide to value added products that are industrially useful. For example, short chain alcohols and short chain organic acids. Currently we are working on lanthanum removal and recovery from electronic waste, because if you look at the lanthanum, it is a rare earth element and it's very scarcely found on our natural resources, and therefore it is necessary to remove and recover from secondary sources, and it is also widely used in many electronic devices and medical devices also. And we use a specialized protein for this purpose, which is landmodulin, and it is produced by a bacteria called Methylobacter extorquens, and we specifically work on building certain bioreactors or systems, and also try to enhance the production of this protein for industrial scale application. And another main focus is on squalene production, which is a very industrially useful product that is used in cosmetics and also for therapeutic purposes, because squalene is mainly obtained from the liver of shark, which is environmentally not feasible, and it is also deterioratable. So we use simple yeast like Saccharomyces cerevisiae or Pichia pastoris for enhancing the production, and we apply our bioreactor systems for enhancing the production and for its purification and related bioprocessing strategies. The current research on ammonium removal from wastewater is very special, because it is an engineered system where we use a consortium of microalgae and nitrifying bacteria as well as denitrifying bacteria, where we convert the toxic ammonia into harmless nitrogenous gas. And because in a conventional treatment system where we have to supply energy in the form of aeration, so in this system, so we totally avoid any external aeration or extraction for carrying out this process. My student Sumit will further explain, and before that I would like to mention that the bioreactors are some of the main important things which we specially design for various bioprocess, and we study the kinetics of the process that is involved and also optimize the process for better efficiency. We have many such reactors that we have made in our lab, for example inverse fluidized bed reactor and moving bed bioreactor and photo bioreactor and many type of reactors which we made, and these are specially made for a particular bioprocess system or operations. And Sumit is my student who will explain more on the ammonium removal from wastewater. In fact, Sumit is also working on sulfide removal. If you look at this sulfide, which comes in the form of hydrogen sulfide, it is a toxic gas. He is also working on one aspect of removing this toxic sulfide from the environment by special group of organisms called as. And one of the projects that he has mainly looked into along with other students, especially who are now currently doing postdoctoral fellows, is the ammonium removal. Sumit will be able to explain it much in detail.
Hi, I'm Sumit Kheria. So we are working on the removal of ammonium from wastewater. Ammonium is one of the most prominent nitrogenous compound that is present in wastewater. It causes acidification, harmful algal blooms, and the most common sources for ammonium is domestic sewage and industrial waste plus agricultural runoff. So we thought to remove this harmful ammonium from the wastewater, and the conventional methods that are available for treatment of ammonium from the wastewater are activated sludge process, but those processes require a lot of aeration, and that is the one of the aspect that contributes to the develop a process or a system where we can reduce this cost by utilizing the in situ oxygen. So we utilized a bioengineered system where we used a consortia of microalgae and bacteria. These microalgae, they are capable of producing oxygen, and that oxygen is utilized by these bacteria, when the nitrifying bacteria. So the ammonium is first converted to the nitrates by bacteria, and under the dark phase in the anoxic condition, these nitrates are further converted to nitrogen by these denitrifying bacteria. So we were successfully able to produce a symbiont of this microalgae and these bacteria, and finally we were able to optimize the process, and we utilized the real world data with the scientific modeling to get the maximum ammonium removal from the wastewater, and we were able to our system was able to demonstrate around 91.33% of the energy cost reduction in comparison to the wastewater treatment plants that use the external aeration.